All right, so I wanted to look at an example 8.16 in your book here. All right, so example 8.16 is one where I've got a nodal analysis. All right, and essentially they go through and get to a set of equations that looks like this. In other words, in terms of the four unknown node voltages, they get this set of relations. Now that's pretty easy to solve in Matlab. Now, where did this come from, right? Remember where this came from is each of these is a KCL equation of some sort. Right? You can go to the book to see how they derive that, but each of these is a different KCL. Okay. Now, let me move this to the side. What I want to do is I want to look at how to do that. So let me do a new script. And I'm going to save this guy as Matlab matrix example. Okay. And I'm going to define, first of all, this guy right here. All right. So I'm going to say -1, 0, 1, 0. All right, that's the top row. In other words, this guy right here. So what I'm going to call this is AX equals B. So I'm going to define A, and then I'm going to define B, and then I'm going to solve for X. All right, so what I've done here is I've written the first row, -1, 0, 1, 0. Now to go to the next row, I put a semicolon in there. And I say, in this case, it looks like I've got J, and then -1 plus J. Then I have 2 minus J, and then I have -1. Okay. And then I go to the next row. It looks like I have -J, and then I have 1 plus J. And then it looks like I have -3, and then I have 2. And then on the next row I have 0, 0, -1, and 2. All right, so now notice what I've done is I've put a semicolon in between each row. Hit enter. Okay. And now I'm going to try to enter the B vector. All right, so B is basically this guy here at the end. So I'm going to do -12 semicolon 4 0 semicolon -4. Okay. So if I look here, let's save that real quick. One thing I want to do is just show you what this looks like. Let me paste that in there right quick. Okay. So, all right, what this has done is it's written out for me the columns when I wrote that. Let me see. Let me see if I can make this bigger. I'm going to close some of this stuff in my Matlab. All right, let me type A again. All right, there we go. That looks a little cleaner. Okay. All right, so I can see. All right, what do I have? I have -1 in this entry. I have 0 in this entry. I have 1 in this entry. 0 here. Now if I go to the next row, that's where I can see. Okay, I've got Matlab writes this as 1I. Writes this as -1 minus I. 2 minus I minus 1. All right, so if you follow that through, you'll see that it matches with this guy. So let me go back. All right, so if this is what I have, remember what I want to do is I want to say X equals inverse of A times B. Right? That's how I solve this thing. So in Matlab, I can just say X equals inverse A times B, and I'll get the answer. So I run that guy. Oh, I made a mistake when I did that. Okay, what did I make? What mistake I made was I set up my B vector wrong here. So you look at this real quick. In my B vector, I have -12, and then in the second row I have 4, and then in the next row I have 0, and the next row I have -4. I got a mistake that first time because I didn't put a semicolon in between the -12 and the 4. So now let me run it. Now it's okay. Now no mistakes. Okay, so there I get my answers right here. This is my x vector. And if I look at, all right, if I want to get that in, I want to get the magnitudes of that, I can type abs of x. And if I want to get the angles of that in degrees, I take angle of x times 180 over pi. Run that. Okay, so I can see there, these are the magnitudes of each of the voltages, and these now are the angles of each of the voltages. And if I compare to what is in the book, let's see if they get their answer. Okay. Yep, they get the same answers here. So see, here's 10.7, 14.14, 5.36, 4, and then you see they get the same angles. Okay, so this is I'll give you this file as well, but I think what you'll find ultimately is that this approach of using Matlab is actually going to be a little bit easier for you, I think, in a lot of cases. All right, so where's that particular file? Here it is, down at the end. Okay, so this, I think you'll find that this particular approach of putting these into Matlab will be a lot easier for you. So give that a shot. I'll upload those, and hopefully it'll be helpful.